To generate this kind of plot, you have to go to stopping range tables, and you have to specify the IN, and you have to specify the target and the elements in the target. And before doing the calculation, select the stopping power unit as electron volt per Armstrong and do the calculation. And to generate this kind of plot, so in this case it is actually atom collision is there, ion collision is there, and its recoil is also there. Okay, so in trim calculation you have to specify all the details, your layer details and your ion data. And in damage calculation you have to choose the detailed calculation with the full damage cascades, then only it will give the recoil data. Okay, and uh, better best to select a total number of 10,000 ions, and you can specify the autosave at some 10 or 20 ions. So the thing is the program is very it take long time, so it might there will be possibility that it can like uh, lose the data from its RAM, computer RAM. So better to save the data after 20 ions or 10 ions, so the data will be saved. And to generate this plot, actually we need ion collision detail and recoil detail information. So you have to go to collision details here, and you have to select S. So if you choose S, then only the recoil information will be saved to the text file, collision.txt file. So you have to give S. And one important thing is here I am generated this plot only for uh, 400 4000 Armstrong. Okay, so if your layer thickness like material thickness is some 200 nanometer, then you have to just consider another 200 nanometer of substrate. So this substrate, suppose it is some 200 nanometer, then better you give substrate thickness is also 200 nanometer. So you will get this kind of plots. So the thing is like if you give the substrate thickness as higher than this, the problem is the program will take a longer time to complete it, because it have to calculate all the each atom collision and corresponding cascades. So it's a like a, very hectic job for the CPU and all. So better you choose only small region. Okay, so you'll get a intermixing information also from this simulation. Then you run the program. Okay, I'm just selecting some material. So it will ask for this question will ask. So you just continue with the yes. So it will start the program, and you can do one thing. If it is taking long time, you can minimize this window, so it will be very fast. So the data will be saved in the software. No need to worry about it. And once it is done, I'm just pausing the program now. So you have to export few data. So these are the data you get from the simulation. So you have to save all the data files. So if you click on F, you can save the data file. Okay, so like every data file you have to save. And this kind of plot can be generated from the data saved to like ion or recoil distribution data. We can generate this kind of plot, and this kind of data can plot can be generated from the ionization file. Okay, so you have to once the like simulation is completed, you have to save all the files. So by clicking this F button, and to generate this kind of plot, so in this case you can see the projectile entire projectile range is plotted here. So it is around 14 micrometer the atoms are like ions are penetrated into the material. Okay, so in that case, you have to give the entire thickness of the substrate. Not entire thickness. The thickness of entire thickness of substrate might be 0.5 mm, but only some 13 micron only penetrated into the substrate. So you have to just specify that thickness. Like if it penetrates to some 30 micrometer, you have to give 30 micrometer. Okay, so if you give the complete length thickness of the substrate, the program will take longer time to run. So with this much of thickness, you will get the complete data actually. Okay, and when you are saving this data, again you have to go to collision detail, and in this case we are not collecting any recoil information. So if there is recoil information, there will be, you can see some spread from here and here. Okay, so in this case we don't need this that kind of data. So if you include such a recoil information, it will be, the file will be very high, very big, like 2-3 GB will become. So processing such data is very quite difficult. So you have to give no. So data will be stored for ions, store data for recoil also. So we don't need recoil data. So just give no. And again, keep all these parameter as it is, like auto save you have to give, and some 10,000 ion will be get enough to get a statistically valid data, and you have to give all the other information. Okay, then you have to run the program, and while running, to increase the speed of this program, we can just minimize this window. Okay, and after completing the simulation, you have to save all the data files by clicking the F button. And this data is like, this plot is from the ionization data. So so once the simulation is completed, you have to save all the files.